point you to the right direction. So 6.4, this is when we have to, or when we're using the normal curve, a normal distribution to approximate the binomial. So in the sense that if you remember in chapter 5, and that's what chapter 5 is the binomial distribution. And now if we have something, if we're using the binomial distribution and try to find something that have a lot of not a lot of outcome, but a lot of sample, or in terms of a lot of trial in the terminology of binomial distribution, instead of do it binomial by hand, or binomial distribution will be a little bit tedious. They found out that if we use an approximation normal, or we using the normal distribution, we can find, we can approximate that probability. And in order for us to find that, in order for us to use the normal to approximate the binomial, we need to fit these two criteria. And again, the first two criteria, or the two criteria that need to be met, is the n, which is the total number of trial multiplied to the probability of success, have to be bigger than or equal to 10. And the n multiplied to the 1 minus p, which is the probability of failure, or 1 minus p, have to be bigger than and greater than 2 to 10. Okay, so if those two conditions met, we can use the normal to approximate the binomial. Okay, so but if you remember in chapter 6.1 and 6.2, I mentioned that in order for you to do the normal CDF, or the inverse norm, you need to have two items. And that's what we have to do in this case, or in this 6.4, is you have to find the mean and you have to find the standard deviation. So if you remember in 6.1, whatever information they give us, we just use it because we deal with the population. Whatever information they give us in 6.1, in terms of the population mean and population standard deviation, we plug into our calculator and we find our answer. The only thing different in 6.2 is we deal with a sample, so we have to convert the standard deviation, the population standard deviation, to become a standard error, which take the population standard deviation divided by the square root of n. Now, in chapter 6.4, we have to do two things. Before we can use this normal distribution, we have to do two things, which is we have to find the mean. And to remind the mean is the n times the p. And we have to find the standard deviation, which is a square root of the n times the p times the 1 minus p. So that's what you have. That's one of your goals in 6.4, is you need to find this mean and you need to find the standard deviation. And go back to this item here. This is the criteria that we mentioned is this. The binomial distribution is discrete, and the problem is because the binomial distribution is discrete and the normal distribution is a continuous item. So in order for us to use the normal to approximate the binomial, we need to do one thing extra, is we need to adjust our endpoint. Okay, so if our criteria met, which is the n times the p is bigger than 10 or equal to 10, and n times 1 minus p is bigger than or equal to 10, once you find the mean and the standard deviation, the next thing we need to do is we need to adjust our endpoint. Okay, to make it more accurate, we need to do the adjustment. So on top of find the mean and find the standard deviation, we need to find the adjustment of this endpoint. And to be in short, ladies and gentlemen, this is what you need to do, is you need to ask yourself this item here is, at your particular endpoint, do you include the endpoint or you exclude the endpoint? Okay, if you include the endpoint, you have to make it bigger by add them. Well, Depend on which way we heading. We have to make the area underneath the curve bigger. Okay, and if you exclude the endpoint, we have to make the area under the curve smaller. Okay, so looking at this item here, this is what we have is in chapter 5, we flip the coin and we probably just flip 10 or 20 times. And this one here, they ask you if we flip the coin 100 times, right? And the probability of come out head, which is successfully land on the head, is 0.5 because it's a fair coin. Now they ask you, what is the probability that you flip the coin 100 times and the coin land on head between 45 to 55 times inclusive? Inclusive, well, exclusive in this, it depends on your question. And in this case here, exclusive, okay? Exclusive because it's only asks you for between 45 and 55, and that is very big, ladies and gentlemen. Exclusive is basically tell you that we do not include the endpoint, and if we do not include the endpoint, meaning there is no equal sign. Okay, so looking at this item, if we do not include the endpoint versus we include the endpoint in terms of this thing here, so you ask yourself this question. Okay, let me go with this route. So think about this red item right here. Give me 1 second. Think about this red item, red box. So if my red box, if you look at this red box here, that is exactly between 45 and 55. Okay, like I mentioned earlier, in addition to find the mean and the standard deviation, we need to, you must adjust your endpoint. In order for you to work the normal, approximate the binomial, you need to adjust your endpoint. So if you look at the first item right here, they ask you between 45 and 55 exclusive. So what does it mean exclusive? Meaning we do not include the 45 and we do not include the 55. Meaning we have to make our area smaller. Okay, so if you look at this question, you ask yourself, or let me ask you, if we were to have this box, if I were to have a green box and I were to have a blue box, do you agree that the green box is smaller than the blue box? Obviously, right? Looking at this thing here, how can you make your area smaller? Okay, and to make your area smaller, as you can see, the red box is your original 45 to 55. To make it smaller, everybody see that all we do is we make it a little bit smaller in terms of move it inward on the two endpoints. Okay, so if we move it to the left, this is come down to this. If you move it from your endpoint, if you move it to the left, you minus 0.5. If you move it to the right, you plus 0.5. So as you can see right here, 45, I want to make it smaller. I move it inward, I move it to the right. And because I move it to the right, I add 0.5. 55, I move it inward, which is I make it smaller. I subtract, I move it to the left, I subtract 0.5. And if you compare this to the, if you compare this item to the bottom, because we include the endpoint, right? Because we include the 45 and the 55, we need to extend this area a little bit bigger. So that's why on the left-hand side, I need to move to the left, which I subtract the 0.5. And on the right-hand side, I need to move to the right. I need to add 0.5. Okay, so that's the idea of this figure in the sense that you need to ask yourself two questions. Do you include the endpoint? And now, do you move it to the left or to the right from the endpoint? If you can answer that, this section will be very doable. Okay, the next list of items or the next slide is basically tell you what I just told you, that if your area to the right, if your area to the right and you want to include the endpoint, If your area is this, you will see later, if this were to be my endpoint, the red line, and I'm looking for the area to the right, I need to extend this, make this area bigger. And to make this area bigger, I need to extend it to the left by subtract 0.5. And again, if I look at the next 3 slides, you will see that if we're looking for the area to the left and you include the endpoint, you need to make it bigger. And to make it bigger, you need to, again, this is, let's say that this is your, this is your endpoint somewhere here, and you need to include the endpoint. And because we want to include the endpoint, we need to extend this area. And to extend this area, everybody see that I need to add more item to extend this to include the area. Okay, so in the sense, this is your typical question that they will ask you. And if you look at this thing here, they ask you the same question as before. Is they either ask you for the area to the left, the area to the right, or the area in between. Okay, and all of this figure right here is you include the endpoint. And because you include the endpoint for this item, you subtract. You include the endpoint for this item, you add, and vice versa in this too. Now, if they have exactly 1 point, if they have exactly 1 point, then this is all you have to do. Is in order, if you remember, we cannot find the area at one particular point. We have to make it, because of the length times the width, we have to make this a little bit bigger by doing subtract on one side and add on the other side. And yes, ladies and gentlemen, the 0.5 is the fixed number. We just want to make a small adjustment to the endpoint, and the small adjustment to the endpoint that we need to make is to either add 0.5 or subtract 0.5. That's it. We don't add any other number. We don't need to subtract any other number. You either move to the left by subtract 0.5, move it to the right by add 0.5. Okay, so looking at this item, and one thing is, if we were to have a paper test, which unfortunately we don't, if we have and I believe this item will be on your formula sheet for your paper test, and I believe is on your formula sheet for your final exam also. So looking at this item, this is basically tell you that if they ask you for binomial distribution and they ask you to find at one particular point, if they ask you find the probability exactly 2 people, right? Find the probability exactly, which is x equal to a number. This is what you need to do to adjust your endpoint by add 0.5 and subtract 0.5. Find a smaller limit and smaller boundary by subtract 0.5, and the upper boundary by add 0.5. If the endpoint is included, if they ask you to find the x is bigger than the area, greater than the area, and the area is included, we need to subtract 0.5. And again, if it does not include it, we add 0.5 in the sense of this item, and vice versa the last two. So basically they tell you that whatever the binomial distribution asks you, this is what you will ask to find in the binomial distribution. This is the correlation in the normal distribution. And yes, all we're doing is we add 0.5 and we subtract 0.5. Okay, so let's take a look at the problem, and hopefully when we look at the problem, you have a little bit better, when I illustrate the problem, it's a little bit better in terms of find how to determine if you add or how to determine if you subtract. So this is the procedure to find, to using the normal approximate the binomial. So the first thing is you want to test your criteria. You check your condition, which is the n times the p have to be bigger than 10. The n times 1 minus p have to be bigger than or equal to 10. Both of them have to be bigger than or equal to 10. If one of them does not met, then we cannot use it. Okay. Once you check your criteria, you check your condition, You need to find your mean, which is the n times the p, which is your mean. And you need to find your standard deviation, because without the mean and without the standard deviation, we cannot use the normal distribution, okay? And the standard deviation is a square root of n times the p times the 1 minus p. Once you have that, you need to determine your endpoint, whether by add 0.5 or subtract 0.5, and then sketch your curve. Or, step 4 and step 5 is interchangeable. You can sketch the curve first and identify your endpoint later. But again, probably step 4 and you need to move step 4 up to step 3 and step 3 down to step 4. Sketch them first. Give yourself an idea of where is the area that you need to looking for. Okay, that is very crucial to find the endpoint. And once you have that, you basically either using the table A1, A2, or the technology, which is your calculator. As you will see that in chapter 6, the calculator feature is the same feature throughout. Okay, the only thing changing is the information. Okay, so let's take a look at this example 1. So in example 1, this is what they give you. The n is your sample size. The p is the probability of success, or in this case, the proportional proportion, which is 0.86. And the x is the number of trial we want to be success, right? So using the normal approximation to find the indicated probability. So we, to put this in a real problem perspective to make it easy to understand, let's say that, you study for this test. Let's say that I give you a test, 115 question test, and you study. So I know you study, and I say, I give you the probability of for each question, since you study, for each question, the probability of you have it right is 0.86. Okay, just put in some perspective. This is the question is, what is the probability of you go and take the test and you have greater than 98 question correct? So out of 115 question, you will have more than 98 question correct, greater than 98 question correct. Okay, so again, just put in some perspective of the question they ask you. Right, there is 115 question. The probability of each question correct is 0.86. Now, what is the probability you go in to take the test? You have more than 98 question correct. So we can see that looking at this item, the mean, you test your condition, the n times the p, you see that it's 98.9. And the n times 1 minus p is 18.1, so it met the condition, right? It met the condition that we need, bigger than 10. So now, once it's met the condition, we can go ahead and use the normal approximation. And the normal approximation require us to find a mean and find a standard deviation. The standard deviation is a square root of 15 times 0.86 times 1 minus 0.86, or in another case, times 0.14. So if you multiply those and then you take a square root, you should have 3.721021.365. And if you remember from Thursday, I told you use as many decimal as you possibly can. Don't round your answer too much, because it will give you a wrong answer. You want to round your answer as a final answer. Okay, so looking at this thing here, once you find your mean, once you find your standard deviation, we need to ask ourselves, what is the area that we're looking for? So we know that 98 is somewhere here. We're looking for the more than 98, right? My mean is 98.9, so 98.5 is somewhere here, 98 is here. Basically, this is what we're looking for, is because they ask us, we need to find out probability that is bigger than 98. Do you agree that anything to the right of 98 is bigger than 98? The 99 question, the 100 question, the 101 up to 115. Again, what is the probability of you going here, take the test, and you have 99 question correct, or 100 question correct, or 101 up to 115 question correct, right? So to find this probability, to use the normal approximation, we need to adjust. You must adjust your endpoint. So let me ask you, do we include this 98? We have the 98 here. Do we include this endpoint? Is there an equal sign underneath this inequality? And hopefully you say there is no equal sign underneath the inequality, meaning we do not include this endpoint. And if we don't include this endpoint, everybody see that if we don't include this endpoint, meaning we have to make this area smaller, right? And if you want to compare, let me make this obvious, right? If you want to compare, the black line is my 98 line. Do you agree that the red box do not include the black line? And I want the area to be smaller so that I don't include the 98. That's why the red box is what I need. The green box cover the 98. So I don't need the green box, right? If you look at the two box, we clearly see that the green box include the 98. And you just answered this question here, we don't include the 98, right? So looking at this item, because we don't include the 98, everybody see that we need to move my endpoint to the right. And if you remember, I told you if you move it to the right, all you need to do is add the 0.5. Whatever your endpoint is, from your endpoint, if you move it to the right, you add 0.5. If you move it to the left, you subtract 0.5. Okay, so the first question is find the mean, find the standard deviation. That's the first thing you need to do. The second question is you ask yourself, do I shade it to the left or do I shade it to the right? And now, do I include my endpoint or do I exclude my endpoint? How do I include my endpoint or how do I exclude my endpoint? So if I move it to the right, I add 0.5. And once you add 0.5, this is all you need to do, ladies and gentlemen, is we use the same feature we've been using, which is normal CDF. My lower limit is not 95, but it's not 98, but it's 98.5. You need to adjust it. In 6.4, your endpoint will always be 0.5 because you always have to adjust them by add 0.5 or subtract 0.5, okay? And then again, this thing keep on going, so it's gone humongously big, which is, in this case, I put 10 million. My mean, 98.9. My standard deviation, 3.721021365. And if you type this thing in, you can see that the probability based on this item, the probability of you have 99 question out of the 150 on 100 out of 150 or 101, so on and so forth, is 54.28% or 0.5428. Okay, so the feature of this item is the same. Before I continue, anyone have question how to utilize your calculator? I know some of you probably have question with the endpoint, but let me go through B, C, and D. Hopefully you see that B, C, and D is give you an idea of how to adjust your endpoint. But before we do that, anyone have problem of how to find the mean using your calculator, how to find the standard deviation, plug in the number in your calculator, or how to use or find a normal CDF feature in your calculator? All right. If you don't have question, let's take a look at B, C, and D here. So in C, in B, they ask you find the probability of X less than 90, less than or equal to 90. So if you look at this item here, if you scan this item, this is my 90, and I'm looking for the area less than or equal to 90, right? So do you agree that anything less than 90 will be on the left of 90, right? So basically they ask you, if you go into this, take this test, what is the probability of you have one question correct, two question correct, up to 90 question correct out of the 115 question. So in terms of this thing here, do we include the endpoint. And hopefully you guys say, yes, we include the endpoint. Again, the difference on how to determine include or exclude, if there's an equal sign, which is the line underneath your inequality, we include the endpoint. If we don't have the equal sign underneath the inequality, we exclude them. So in this case for B, we include the 90. So I want to make this area, this orange area bigger. And if I want to make it bigger, everybody see that I need to move the area. I need to move my endpoint to the right. I want to extend this area. I need to include this 90. Again, the difference between this problem versus the previous problem is the previous problem, we find the area to the right. In this particular problem B, we find the area to the left. And because the area to the left, I want to make this thing bigger, I still move it to the right. And if I move to the right, I add 0.5, which in this case, my endpoint, my upper endpoint will be 90.5. Okay, why is that my upper endpoint? Because again, we're looking for the area to left, which the smaller limit is something here, which is negative infinity, go all the way up to 90.5, which is my upper limit. My mean is 98.9. My standard deviation is 3.72, which there are a bunch of that small place on the back. So once you type this thing in, this is the probability that you get X less than 90. Okay, again, we approximate them. So the answer might not be exact, but it's very close. It's very item in terms of the accuracy of this item here. But in order for you to use this feature in 6.4, you need to adjust your endpoint. And again, to adjust your endpoint, you always have to, you must, is a must, ladies and gentlemen. When you see that using approximate normal, then you must adjust your endpoint. And to adjust your endpoint, you either subtract 0.5 or add 0.5. Okay, so let's take a look at C. If you look at C, same thing go. If you look at C, let's clear this thing out. We are looking for the probability of X between 55 and 100, right? This is what we're looking for. We're looking for the probability, or in this case, the area between 55 and 100. And hopefully you guys see, we do not include the endpoint. We do not include this endpoint, meaning, what does that mean? Do you agree that if I don't include the endpoint, and again, I obviously making that item big so that you can see. If I don't include the endpoint, which kind of box should I use? Do I use the red box or the orange box, right? Let me use the yellow. So if you look at this thing here, if we don't include, we must not include this item, right? Because they don't tell us that the equal sign. So if I don't include the 55 and I don't include the 100, you can see that we cannot use the red box because the red box include the two endpoints. Meaning in this case, we have to use this yellow box, meaning at 55, this is what you ask yourself is at 55, how do I adjust to make this area smaller? At 55, I have to go to the right. And if you remember, at 55, I go to the right, meaning I add 0.5. At 100, I go to the left. I need to subtract 0.5. So again, 55 add 0.5 to give me 55.5. 100 minus 0.5 to give me 99.5, which my lower limit 55.5, my upper limit 99.5, my mean is 98.9, it's the same mean as before, and my standard deviation is the same. Okay, so again, that's the idea you have to ask yourself is from the endpoint, do I make my area bigger or do I make my area smaller? And if I make it bigger, how can I make it bigger? Or vice versa, if I make it smaller, how can I make it smaller? Okay. And identically or similarly, as you can see, the difference between C versus D, the difference between C versus D is there is a equal sign. There is an equal sign underneath, meaning you need to include this item. You need to include this endpoint. And hopefully you guys see that to include this endpoint, I need to make this item, let me make it obviously. I need to extend this area bigger. I need to, whatever the green shaded region that I have right here, I need to make this green shaded region bigger so that I can include the 56 and the 110. Okay. And to make it bigger, everybody see that at the 56, I need to move it to the left. And at the 110, I need to move it to the right. So at 56, if I move it to the left, I will end up with 56 minus 0.5. So that will give me 55.5. And at 110, I need to move to the right. And to move to the right, I need to add 0.5. That's why I have 110.5. My mean and my standard deviation is the same. And again, your feature from your calculator is the same, which is the normal CDF. Okay, so again, this is the idea of 6.4. The idea of 6.4 is we give you some problem. You need to ask yourself, what is the mean? What is the standard deviation? Which area am I looking for? Am I looking for area to the left, the area to the right, or the area in between? And the newest item in 6.4 is you need to adjust your endpoint. And to adjust your endpoint, you either subtract if you move to the left, 0.5, or add 0.5 if you move it to the right. So let me ask you guys, let me pause a bit and ask a question with this item here, question of how to adjust your endpoint or question of how to use your calculator.
Do you mind explaining how to do the standard deviation again, the 3.721?
Again, you just plug in your calculator. Basically, this is what we have is to find a standard deviation. Let's see. To find a standard deviation for the normal distribution, the standard normal, give me 1 second here.
Okay.
So for the binomial distribution, again, the binomial distribution, the n times the p is the n times the p is your mean, and the square root of the n times the p times the 1 minus p is your standard deviation. So that's this is the formula that we have.
Okay, I see.
Okay. So to find the standard deviation, basically you just take, for us, we have 115, right? Time, my p is 86.86, and my 1 minus p is that. So if you want to, that's what you have, right? Which is 115 times 0.6 times 1 minus 0.6. And then you have to take the square root of that.
Okay, I got it.
Square root of 13.3846. And then that's where I have it. And you have to do that for every problem in 6.4. You have to find the mean and the standard deviation for all of them. And again, you can either do it like this. For me, I do it two step, but you can just type, you can just type it all in 115 times 0.686 times 1 minus 0.86, and again, it's the same. Okay. Just close the parenthesis and close the parenthesis, and you should get the same. So again, you can either, some students like to do it one step at a time. If you want to plug it all in, it's the same.
Okay, thank you.
Okay. All right. So again, once you have that, like I mentioned, this is all we have is you plug it in. Once you find the mean, once you find the standard deviation, like I mentioned, the other thing is find the area. Do we find the area to the left? Do we find the area to the right? Because that tell you what endpoint to start and what endpoint to stop. And the only thing new, only thing new in 6.4, which is the confusing part, is you need to adjust your endpoint. You need to either subtract 0.5 or add 0.5. Okay. So let's put all this together. Let's put this in the real situation, right? So the example 2, the name is Big Baby. So the CDC, which is the Central for Disease Control and Prevention, report that 25% of the baby boy between the age of 6 and 8 months in the United States weighed more than 20 pounds. A sample of 150 babies is in the study. They ask you approximate, and again, that's the keyword. If you try to see what keyword to use, they tell you approximate, and when they tell you to approximate, that's when you use the approximate normal. So approximate the probability that more than 40 baby weight more than 20 pounds. Right. So looking at this item here, and if you say, wait, how do I know which section am I in? Am I in 6.1, 6.2, 6.3? If you remember, 6.1 doesn't, mostly you deal with probability, population. 6.2, if you deal with a sample mean, if they ask you find the probability of a sample mean. Now, if they tell you approximate, that's when you're in 6.4. Is approximate because we don't find the exact probability, we just approximate the probability. Okay, so approximate the probability that more than 40. So again, before we do all that, before we go to the figure, you can test your criteria, or you need to test your criteria. So we know that this is my N. I have 100 baby in this study, and I know the probability of them, one of them weight, or each individual can weight more than 20 pounds will be 0.25, right? So this is what we have is the N is the total, the P is the probability of success, and we need to find the mean, and the mean is basically the 150 times the 0.25. And if you multiply this and you have 37.5, you can see that out of 120, 35 is this, 37 is this, meaning 113 will be the way, which is the N times the 1 minus P, which is bigger than 10, right? So again, most of the time they give you this thing here is bigger than, when you multiply them, is bigger than 10. So this is my mean, and my standard deviation, which is the square root of 150 times 0.25 times 1 minus 0.5. So basically, this is your, if you type in your calculator, you type this right here, the square root of this item. Or you can just type this item by itself and then take a square root. Regardless of how you do it, your standard deviation is 5.303300859. Okay, so once you have that, once you identify your mean, identify your standard deviation, now we need to ask ourselves, what area are we looking for, right? Do you agree that anything greater than is the same as more than, right? So greater than 40 is the same as more than 40. So we're looking for the probability of X greater than 40. We're looking for the probability that number of baby bigger than 40, right? We need to have 41 baby weight greater than 20 pounds. So in this case, what do we have? Like I mentioned to you guys, right? Identify, sketch your item, and identify what area we're looking for. Do you agree that anything to the right of this 40 is greater than or more than 40, right? So again, greater than, more than, less than, right? You have to ask yourself, which item are we looking for? Am I looking for the area to the left, or am I looking for the area to the right? So in this case, I'm looking for the area to the right of 40. Now, do I include the 40? Hopefully you say we don't include the 40. If we don't include the 40, meaning we want to make this area smaller. Meaning, do you see that I need to move it to the right of 40? Because if I were to move it to the left, ladies and gentlemen, do you agree that if I were to move to the left, I include the 40 with it, right? If I were to move to the left, the 40 is here, and I move to the left, I find the area, this area, I include the 40 in it. So I cannot make this bigger. I have to make it smaller, and to make it smaller, everybody see that, again, let me change the color. To make it smaller, basically, we find this area. Instead of find the whole area up to 40, we just find this area to the right, okay? So that's what you need to ask yourself is, do I include the endpoint? And in this case, I do not include the endpoint. So I move it to the right because I'm looking for the area to the right, right? And I don't want to include the endpoint. I don't want to make it bigger. So if I move it to the right, I need to add 0.5. And if I add 0.5, my endpoint will be 40.5. And once you have this thing here, everybody see that once you have this, your endpoint is 40.5. So you just put in normal CDF. 40.5 is your smaller endpoint. Your bigger endpoint will be some humongous number. And the mean will be 37.5. And the standard deviation will be 5.303, right? So again, my endpoint is 40.5 because I move it to the right, I add 0.5. Like I said, your endpoint will always be changed to 0.5 as the endpoint. And again, this thing keep on going, so some humongous number work out fine. And once you have this thing here, the prop percent of them. So again, this is the idea. And if you compare A versus B, if you compare A versus B, you guys stay with me?
Yeah, you just froze for a
Yeah, I
minute.
can hear you just froze for a second. You straight dude.
Okay. Yeah. They show me that my my connection is weak, so that's why I don't know if I lost you guys not. But again, if you look at B, they ask you for the probability of 35 or fewer. Because of the word fewer is either 35 or less, right? So if you look at this item, we're looking for 35 or fewer, meaning again, we're looking for something less than 35. And to looking for something less than 35, this is what you need to ask yourself is, again, probability of X less than or equal to 35. Sketch your graph, sketch your item, and this is what we're looking for, right? We're looking for the area to the left of 35. So if I'm looking for the area to the left of 35, now let me ask you this question. Do we include the 35? And hopefully you guys see that we include the 35. So if we include the 35, do I use my red box or my orange box, right? Well, the red and orange is let me use the different one. Do I use the red box or the green box, right? If I want to include the 35, that's what you ask yourself it. If I use the red box, it does not include the 35 in it, right? I want to include the 35, meaning I have to make this thing bigger. And again, And this is where a lot of students get confused in the sense that why on the top figure, right? You say, wait a minute, Mr. Trent, in A, you make it smaller, but you still move it to the right and you still add 5. But on the second figure, you want to make it bigger, but you still move to the right and you add 5. Again, it's correlate to what area are we looking for, right? On top, we're looking for the area to the right of the endpoint, right? On the bottom, we're looking for the area to the left of the endpoint. So it's not, it's not that we're moving to the left all the time or we move to the right all the time if we want to increase or decrease, right? You ask yourself is your shaded region, how can you make your shaded region bigger, or how can you make your shaded region smaller, right? And again, it's depend on where your shaded region. So I cannot tell you that, after you do after you do a lot of problem, you will see when to move and when not to move, when to move to the left and when to move to the right. But right now, the main concept is ask yourself, whatever your region that you shaped, whatever you shaded your region that you try to find, right? Do you shade it to the left or shade it to the right? And because I shaded to the left, I want to make this region bigger. I want to shade it more. And to make it more, I need to move to the right to increase more item, right? And last time up here, because I make it less, so I have to still move to the right because my region is on the right, okay? So that's what you need to ask yourself in that item or in this endpoint adjustment. So this case, because I shaded to the left, and again, I have to move to the right, and to move to the right, I still add 0.5. So again, it's not the area that we add or subtract. It's where do you move from your endpoint? Do you move to the left of the endpoint, or do you move to the right? Do you want to increase the area or decrease the area? Okay. So again, question here with the A figure and the B figure here. So again, once you find the endpoint, everything else hopefully is just a smooth sailing, because my endpoint is 35.5 because I add 0.5. And I'm looking for the area to the left. So my small endpoint, my lower limit will be some negative humongous number. My upper limit will be 35.5. And again, my mean is 37.5 and my standard deviation is 5.3, which a bunch of decimal behind, a bunch of number behind. So once you have this thing here, this is what you have is 0.3530. Okay. So again, look at this item, see if you can identify where to move in that case. And let's take a look at the last item. And ladies and gentlemen, this word is very important. This word here is very important because it tells you to either include the endpoint or exclude the endpoint. Okay. So in this case, they ask you to approximate the probability that the baby weight more than 20 pounds is between 30 and 40 of them, right? So we want to find the between 30 and 40. So in this case, they have to tell you, do you include the endpoint or you exclude the endpoint? So in this case, we exclude the endpoint, meaning we find the probability of 30 less than X less than 40, of X, the number of success is between 30 and 40 that does not include the 30 and the 40. Okay, so if we do that, same way, same item, we need to ask ourselves, sketch our graph. And that's the most important thing. And you will see that from chapter 6 and chapter 7 and chapter 8, you want to sketch this normal distribution curve. You want to sketch this normal curve. And we're looking for in between, which is no sugarcoating. We're just looking for in between this item here, right? So do we include the endpoint? Do we include the 30 and the 40? And hopefully you guys say that no, we do not include it. And if we don't include it, everybody see that we're looking for, we want to make this region smaller. And if I want to make this region smaller in the 30, at the 30, everybody see at the 30, I need to move it to the right. And if I move to the right, I add 0.5. And at 40, I need to move it to the left. To move to the left, I need to subtract 0.5. Okay, so that's why my new endpoint is 30.5 and 39.5. And like I mentioned, yes, in 6.4, your endpoint will always be 0.5, except the negative 1,000 or negative 1,000,000 or positive 1,000,000, right? But if you have whatever other endpoint you have, it will always be 0.5, because you will always either add 0.5 if you move it to the right, or subtract 0.5 if you move it to the left. So everybody see right here, why I add 0.5 on the 30 and subtract 0.5 on the 4, because I want to narrow this area down. And the only reason, or the only way that I can narrow this area down, is to move it inward from both endpoints, right? I cannot narrow it this way, because whatever endpoint I have, you must, whatever endpoint you have, you either must add 0.5 or subtract 0.5. So we cannot just add 0.5 at the 30 and add 0.5 at the 40, because we don't include the 40, right? We cannot include this region if it's not in our criteria, right? We cannot include the 40. So that's why I asked you guys to ask yourself, right? At the end point, do I move to the left or do I move to the right? And in this case, once you find your endpoint, again, hopefully everything else is just a smooth sailing, because my left endpoint is 30.5, my right endpoint is 39.5. So in this case, the smaller limit, my normal CDF, the smaller limit is 30.5, my upper limit is 39.5, my mean is 37.5, and my standard deviation is 5.303300859. And once you have that, that will be your probability. That will be the approximate probability of this region. Okay. So again, hopefully you guys see, one thing I keep on mentioning, and I know some of you say, no, it's not, Mr. Tran. But again, the calculation itself, right? The calculation itself is not difficult. The calculation itself is you just use a feature in your calculator. We bypass the formula and bypass everything. Just use the formula, the feature in your calculator. But how do we get to that part is the challenge, right? The challenge is not to find the answer. The challenge is how you derive to the answer, right? So first of all, question here with A, B, or C. Let's take a look at another problem, and hopefully the third time around is a little bit clear. If not, we have one more problem. Let's take a look at example 3, and they tell you stress at work. So in a poll conducted by a general social survey, 81% of the respondents say that their job were sometimes or always stressful. 200 workers are chosen at random. And A, they ask you approximate. Again, approximate meaning we have to adjust our endpoint. We need to approximate something. Approximate the probability that 160 or fewer find their job stressful. So again, they switching the question on you if you say, oh, this A is not the same as the previous A, because now it's the previous B. But anyway, look at this thing here. Let's identify what is the N. We know that there are 200 workers in this that we take out, right? We based on this statistic, based on this pool, we take this 200 worker out, and we say based on this result, out of this 200 worker, how many of them, right, what's the probability that 160 of them or fewer find a job stressful. So the P here will be 0.81 because the percentage they give us, right? This problem actually easier than the previous problem because you don't have to worry about the 6 to 8 weeks old and the 20 pound or what the number. This thing here, the only two number they have is the percentage, which is the probability that the person say that their job is stressful, versus the 200 is the total item, or in this case, the total number of worker we have. We can test the N times the P, and that is also our mean. N times P is 196, meaning 38 is the N times 1 minus P, okay? If one on average 121 or 162 of them say that their job are stressful, then the leftover will say that their job is not stressful, right? So again, you can see that N minus 1 minus P is bigger than 10. And that's my mean. And my standard deviation is just the same as before. It's just different number. Instead of 150 or 115 prior, we have 200 multiplied to 0.81 multiplied to 1 minus 0.81. So we will get a square root of 30.78, and my standard deviation is 5.5479726, right? So if those are my two items, and that's the only new item in 6.4 in terms that we have to actually find the mean and we have to actually find the standard deviation. If this thing were to be in 6.1 or in 6.2, they would tell you the mean is this, the standard deviation is that, right? This thing here, the problem itself, if you look at the problem itself, they don't say anything about the mean. They don't tell you anything about the standard deviation, right? They just say that this is the percentage we have, and this is how many items we are taking out. And again, if you see the approximation, you have to know the mean, which is N times P, and the standard deviation is this right here. So to correlate or to relate this back to a previous problem, we see that 160 or fewer, meaning we include the 160, and we're looking for X less than 160 or equal to 160, right? 160 or fewer. So if we look at this item here, if you sketch your normal curve, do you agree that 160, again, doesn't matter where, but 160 is here because we know on average 162 is at the middle, so 160, but it's, again, doesn't matter where the 160 is. All we care about is, do I shade it to the left of 160 or do I shade it to the right of 160? And because I'm looking for less than 160, I shade it to the left. And if I shade it to the left, and now the new question comes is, we cannot use in 160 to approximate the 160. We have to adjust our endpoint. So do we include this endpoint? And hopefully you guys say yes. To include this endpoint, everybody see that we need to extend this area a little bit bigger. And to extend this area a little bit bigger, I need to move this to the right to make it bigger. And to make it bigger, I need to add 0.5 because I move it to the right. And if I do that, you can see that the endpoint is 160.5. And again, what is my lower endpoint? My lower endpoint would be a negative, some humongous number. My upper endpoint would be 160.5. And my standard deviation is 162. My my standard deviation is 5.547. So looking at this item here, like I mentioned, once you find your mean, once you find your standard deviation, now you need to adjust your endpoint. And you plug into the feature normal CDF. My lower limit, like I mentioned, negative 1 million or negative 10 million. My upper limit is 160.5, my mean and my standard deviation. And you will see that this thing is less than, we know that it's less than 50% because, again, the mean is 162, which is 162 is at 50%. This thing here is less than 162, so it's had to be less than 50%. But anyway, looking at this thing here, question with the with the process or the procedure on how to arrive to this 0.3934, or anybody does not know how to plug this in your calculator? All right. Similarly to B, they ask you approximate the probability that more than 150. Again, they did not say more than or equal to, right? They did not say equal to 150 or more than, right? So they only say more than 150, meaning we only looking for X bigger than 150. We have 200 workers. We want to know how many, what is the probability that more than 150 of them say that that job is stressful, right? So looking at this item here, similarly, we already have the mean, we already have the standard deviation. Now we need to ask ourselves, what area are we shading? And again, if you look at this thing here, identical line, the 50 should be somewhere over here, but it doesn't matter, right? It's just give you the idea of what is your lower limit and what kind of area we're looking for. So looking at this thing here, we're looking for the area to the right of 150. So the area to the right of 150 is my yellow shaded area. And now, do you agree that we do not include the 150? There's no equal sign. We do not include the 150. Do I make this yellow area smaller or bigger, right? Do you agree that I do not include 150? I need to make this area smaller. I need to shrink this area a little bit. And to shrink this area, I need to move to the right. Because I move to the left, I extend the yellow more to the left side, meaning I make that area bigger, right? I want to shrink this yellow shaded area a little bit smaller. And to shrink this thing here, I move it to the right. And if you move to the right, you still add. Reminder, if you move to the left, you subtract. If you move it to the right, you add. And you say, wait a minute, Mr. Tran, right? Once again, if you say, wait, up here, we make it bigger and we add. Down here, we make it smaller and we still add. Why? Again, it's not correlate to you make it, it's correlate to the area that you're looking for, right? How can you make that area bigger, or how can you make that area smaller, right? So that's why it's very important to know your shaded region, right? What area are we shaded? Do we shade it to the left or we shade it to the right? Okay, so everybody see why both of them we add them, and both of them I ask you a different question, but the result still you add 0.5, right? On top here, I ask you how can I make the orange region bigger? Down here, I ask you how can I make the yellow region smaller, right? So again, it's not, it's not always add or subtract. It's you have to ask yourself, how can you make it, string it down or extend it bigger? Okay. So in this case, once you have this thing here, we know my endpoint is 150.5, and my bigger upper limit will be some humongous number. So I go back, and again, this is all we have to do is your normal CDF. The smaller limit will be 150.5, and the upper limit will be some humongous number. And your mean and your standard deviation is the same. So once you have that, if you plug it in, you will see that the answer will be more than 50%, 0.9809. Okay, so again, this is what we have, which is approximate the probability that more than 150 find a job stressful. Again, the 150 out of this 200 based on this survey result. Okay, so similarly in C, and if you look at C in example 3, and if you recall example C in example 2, the example 2 we have exclusive. Example 3, we have inclusive, right? Last time they asked you the same thing. They asked you to find the, approximate the probability between whatever the two number they give you last time, but now, they say same thing, go approximate between this item, but now they tell you that it's inclusive, right? Last time they tell you that is exclusive. Exclusive meaning we do not include the endpoint. Inclusive meaning we unfortunately have to include the endpoint. And if we include the endpoint, and that's where the equal sign come in, basically tell you find the probability of X greater than or equal to 155, but less than or equal to 162, right? So this is what we have because of the equal sign. We include the endpoint. If there's no equal sign, we exclude the endpoint. So hopefully you guys see that there's no sugar coating in terms of between. This is my two endpoint, 155, 162, and I'm looking for the area in between. So the area in between of this thing here, and if you remember, or if you look at this thing here, we all include the endpoint. If we include the endpoint, do you agree that in order to include the endpoint, I need to extend this shaded area bigger? I need to make this area a little bit bigger. And to make it bigger, I need to, at 155, I need to move to the left. And at 162, I need to move it to the right. And again, if I move to the left, I subtract 0.5. If I move it to the right, I add 0.5. So in this case, my smaller endpoint would be 154.5. My upper endpoint would be 162.5. Okay, so again, this is because I want to increase, I want to make this region bigger. Okay, because again, the green region below is smaller, right? The green region below is, again, I just want to extend this region a little bit bigger so that I can include the 152 and the 162, right? And again, I obviously make it bigger to see that we need to extend the region. So if you remember prior to this example, we move it toward each other. We move inward, right? Because we make the region smaller. In this problem, because they include an endpoint, we need to extend them out. And to extend them out, we need to subtract to the left and add to the right. So this is my two endpoint. And I know my endpoint for my lower limit is 154.5. My upper endpoint would be 162.5. My mean is 162. This is 162 is my mean. My standard deviation is 5.54. 7972603. And again, if you plug this thing in, you will have 0.4477. So looking at this thing here, question, ladies and gentlemen, question with example A, example 2, A, B, C versus example 3, A, B, C. All right. If you don't have question, let me ask you to take a copy of this thing here. See if you can do this by yourself. See if you can do this. Run out of time. See if you can do this by yourself. As you can see, it's very similar to the previous one. 20, 25 or fewer, more than 17. Between 15 and 20 exclusive, right? So it's very similar to example 2. The only thing different is the N here is 80, the N here is 87, and the P here is 2023, right? So again, see if you can do this problem, and we will pick up on this problem on Thursday. So again,